Hello, our most valued student. My name is Confident. Welcome to our Mathematics N2 revision of the question paper. And this particular question paper was written in, it was supposed to be written in March. As you can see, it was supposed to be written in March 2020, but because of the lockdown due to the pandemic that hit us, they call it the conundrum that hit us, it ended up being written in July exams, but they never changed the question paper. And this is the paper that was written, and I thought of sharing it with you and doing some revision session with you. And let us look at a few instructions. As I said, this is the Department of Higher Education and Training paper, and then it is a national certificate, Mathematics N2, and the time allocated for you to do this paper is 3 hours, and the mark allocation is 100 marks. So the whole paper is out of 100, and you've got 3 hours to complete the paper. Now, as simple as it is, but students sometimes neglect or take for granted the reading of instructions. So whenever they give you the paper, in those few minutes before you start your question, in as much as you are used maybe to answering and revising or writing exams, it is always important for you to read the instructions. So let us look at a few instructions here on this paper. It says you need to answer all the questions, read all the questions carefully, and then one important instruction is number 3, says number the answers according to the numbering system used in this paper. So do not come up with your own numbering system. And then it says also number 4, show all intermediate steps and simplify where possible. So in what they're trying to say is, do not do your working on your rough work, or in your, sometimes your question paper is usually where you do your rough work, and then you find that students sometimes leave the intermediate steps, or they are working in that paper and they only write their final answers. This can lead you to being penalized. So make sure that you show all your working so that you will ensure that you get all the marks. And then says use only black or blue pen. Please do not use Tipex in the exam. It is not allowed. And also do not pick, some students like their work to be neat and colorful. Do not use that, because only the blue or black pen is allowed. And also taken for granted is the part where they say write neatly and legible, meaning you need to be neat with your work. Avoid cancelling, being clumsy with the work. If you're going to cancel, take a ruler and make a neat straight line and start afresh again on the new page, so that your work can be neatly. And legible mean you need your handwriting to be clear. So unfortunately, there is nothing I can do about that. If your handwriting is terrible, you need to improve on your handwriting. I always joke to my students to say, do not write like you are hanging on a tree. And then I myself, my handwriting sometimes can be terrible, but I do my best to make sure that my handwriting is visible enough, or it is clear for the person who is going to be marking the paper. So try your best to be slow for a good handwriting. Now let's look at the first question. This is question 1 of this question was having some parts. So I've got question 1.1. Chances are we'll have 1.2 because they started by saying 1.1. So question 1.1 says simplify the following without using a calculator. So it is the first part where we are doing simplification, and this particular question, as you can see, it is 1 mark. So it is just something simpler for you to do if it is 1 mark. So if I can maybe expand on this work. So I'm supposed to simplify that part. Now, the key thing there that grabs my attention is this power of 0. And if you remember, if I take my calculator to say any number to the power of 0, if I say 99 to the power of 0, you see I'm getting a 1. If I say 47 to the power of 0, I'm getting a 1. If I say 2517, that whatever number I'm using, then I say to the power of 0, I'm getting a 1. Therefore, it means any number to the power of 0 is equal to a 1. So the answer there was simply a 1. That's why it was just 1 mark. The second question, 1.1.2, it is also 1 mark, and I'm still simplifying without using a calculator. And again, if I can expand on that. Now what I want you to see on this one is, it says log in base square root of x of square root of x. Again, if you take a calculator as a proof, I'm just using the calculator as a proof. If I say log 2 of 2, you see I'm repeating the number 2, and 2 is 1. I can say log 55 of 55, I'm getting a 1. I can say log square root of 4, but I must also have here square root of 4. You see it's giving me a 1. So log base square root of x of square root of x, you can also say that this will simply give me a 1. That's why it was just 1 mark question. Let us move on. The next question, again, we're still looking at 1.1, which is 1.1.3. This is 3 marks. It means a little bit of work. We're simplifying without using a calculator in this case. If I can expand that part. So what I'm given is that particular part that I'm given. So the thing that you need to take care of here is, so there is a root sign. So this particular root sign, because they did not indicate any number, it means there is a default 2 in that number. So now when there is a default 2 in that number, if I can just do a little bit of my working. So if they just do that, it means this is square root of whatever it is. And then if you simplify it, it's the same as saying, using laws of exponents, it's same as saying 1 over 2. And you can see the other one, they put a 3, the one in the center here, I mean inside, there is a 3. So what it means is, if they say cube root, this is a cube root of whatever is inside. If I simplify it, it is going to be to the power of 1 over 3. So that's the first part that you needed to solve. So if I can say this is equal to, I have my bracket, and then when I'm having my bracket, I have my other bracket. Now it will be 64, and then it's P30, and then it's Q36. Then I close my first bracket, which has got 1 over 3, and I close my second bracket, which has got 1 over 2. Remember, the outside one, which is 1 over 2, is square root. The inside one, which is 1 over 3, is cube root. And then remember now, in this part, I still have here over. It doesn't change there. It is over. This is okay. Now I need to be careful here, because now you can see that the division line in this case is not this part. It is not affected by any square at all. So I must say all over outside the square, which is negative 2 q to the power negative 5. So this is how you will simplify that. Now if I can move on to simplify this problem, I can then look at 64 actually from here to say what was my 64, so that I don't have a lot of writing. Now 64 can be written in terms of 2. If you say 2 to the exponent 6, I think you can see that it gives me 64. So you need to know these numbers, like 2 to the power 5 is 32, 2 to the power 4 is 16, 2 to the power of 3 is 8. So you need to know that part. So I can actually erase this part and make it in terms of 2, which is 2 to the power of 6. Now when I have expressed that, I can then expand and open this bracket. So how does it go about? the first part that I can do is to multiply these two. It's 1 over 3 times 1 over 6. 1 over 3 times 1 over 2. If I multiply that, it will give me 1 over 3 times and 1 over 2. See, it gives me 1 over 6. That was one way that to do. Or you can take the first one to multiply and multiply and multiply. Move on to take the second one to also multiply that. But it is much better if you just multiply the exponents first outside. And remember, I'm using the laws of exponents here, which say if you are given, for example, p squared and then to the power of, for example, 3. So you are going to say p2 times 3, you see. So that's what I'm using here. That's why I'm multiplying 1 over 3 times 1 over 2. So it becomes 1 over 6. And then when I've got that, I can therefore write and say this is equal to, remember they say don't lose out some working. So you'll have 2 to the power of 6, p to the power of 30, q to the power of 36. This is being multiplied now by power 1 over 6. In this case, we can just have that. It's power 1 over 6. And then divided by, in this case, it is 2p to the power negative 2, q to the power negative 5. And then if we continue our working with that, it then becomes, that's when now I open the bracket, whereby it will be that times that, that times that, and that times that. So if I continue there, it will be 2 to the power 6 times 1 over 6, p to the power 30 times 1 over 6, and q to the power 36 times 1 over 6, and then over 2p to the power negative 2, q to the power negative 5. Okay, and then if I continue with that, I'm going to have now, this is that. This gives me 6 into 30 is a 5, and then the other one is 6 into 36 is a 6. So I've got 2 to the power of 1 times, the next one is p to the power of 5, and then times q to the power of 6, and then this is over 2p to the power of negative 2, and then q to the power of negative 5. Now we continue with it. These are laws of exponents, but now you can see that the 2 and the 2 can cancel. In this case, it can divide. Now you are left, you have to take now this particular p to the top, and you're going to take this q to the top. Now if they are negative, you have to take them to the top, they become positive. So what you will have p to the power 5 times q to the power of 6, using laws of exponents, is times p to the power, the negative 2 will become 2 times q to the power, the negative 5 will become 5. What am I using? I'm using this law which says, in this case, 1 over m to the power negative n, for example, is equal to m to the power of n, or 1 over a to the power negative m is equal to, in this case, it is equal to it's equal to a to the power of m. There is a law. How do they go about? It's 1 over a to the power negative m is same as 1 over a to the power of m. This is a to the power of m. But you need to get hold of my lesson on exponents, and then this will make a lot of sense. Then when you've done that, you can simplify now using the first law, whereby if the bases are the same, you can see there is that base p and p, you bring it together, so it is p to the power of 5 times p to the power of 2. That's the first law you're going to use there. Again, q to the power of 6 times q to the power of 5. So when the bases are the same, you add the exponent. If I can remind you of that law, which says a to the power of m times a to the power of n. When the bases are the same, you say a to the power of m plus n. So here you're going to have p to the power of 5 plus 2 and q to the power of 6 plus 5. Now, which is p to the power of 5 plus 2, it is 7. Q to the power 6 plus 5, it is 11 in this case. So this is how you can simplify this kind of a problem. Now, if I can take you back to the beginning here, right? Sometimes I just to convince myself that is this correct, did I simplify correctly, what I do is I can take a simple value of p and q. Just take any value. For example, let's say let p be equal to 2 and q be equal to 3. So I'm going to use my calculator in this case to enter the values. In this case, I need to enter the values into the original. This is my original there. So if I can enter the values there, so what I have for the top, remember it is just this sign, which is the square root. So I've got a square root and I've got another cube root here. So if for the cube root I say shift, there is the cube root, and then it's 64. Now where there is p, I said p, let p be equal to 2, so it will be 2 to the exponent 30. I hope it will simplify there. And q is 3, which is 3 in this case, to the exponent 36, and then over 2, and my p, we said it is 2 to the power negative 2, and then I have got also my q, which is 3 to the power negative 5. So I've got that. You see, I'm getting this number, which is 22, 67, 48, 16. 22, 67, 48, 16. 22, 67, 22, 67, 48, 16. Something like that. So if this is the number I'm getting, I also do the same. Go back to the final. And in the final, take my calculator, and where there is a p, I also put a 7. So remember, I put a 2. So it's 2 to the power of 7. And then also q is 3 to the power of 11 in this case. See if I'm getting the number 22, 67, 48, 16. It was the same number that I got on the previous one. So you can see that after simplifying, I'm still getting the same answer, which means the top is still the simplified version of that. That is what I use usually just to check if my answers are correct. Now let us look at 1.1.4. In this case, still continuing. It is out of 3 marks. We are still simplifying without using a calculator. So anything that does not have x or y or anything, when they say I must not use a calculator where I can, I usually take my calculator there, try to simplify and see what it gives me. So in this case, I'm given log, I've got log 9 minus log 4, and then over log 81 minus log 16. So that's what I'm having. Remember, when you open the bracket, close the bracket so that you don't, the calculator actually opens the bracket the moment you enter log. So it is your duty to close the bracket, and then so that you don't make errors while you're entering the logs. And you can see I'm getting equal to 1 over 2. So this simplifies to 1 over 2. So my aim then, it is for me to work towards my answer of 1 over 2. So that is the whole aim of this. Now the calculator in this case helps me to know what this simplifies to. Now I must prove this particular answer, which is now better, to prove something that you know, unlike sticking to the part which says don't use a calculator and you just don't even choose to check out what your final answer is. So now let us get 1 over 2 using laws of logarithms. So the first part I think you have to do in this case is to identify the top, which is 9 and 4, identify the bottom, which is 8, 1 and 16. Now the 9 can be written in terms of, 81 can be written in terms of 9, and 16 can be written in terms of 4. So already you can see that this become log 9 minus log 4 over log, now 81 is 9 squared minus 16 is 4 squared. So you can see now I have written everything in terms of like the top and the bottom. Then this becomes, now I have to use the laws of logarithm. There is a law which says if I'm given log in base, for example in base of a of m to the power of b, now what happens is I must drop the b so that you have b log in base of a of m. Now don't worry with the base a in this case because I did not include any base, so by default is base 10. But what is important is see how the b drops down to become that. So we're going to use the same thing here where the 2 will drop down, and even here it will drop down, so that we are having log 9 minus log 4 all over 2 log 9 minus 2 log 4. So this is where the whole trick was. And if you can simplify then this particular question, it means if you can see carefully, we have got a 2 there and we've got a 2 there, so it means we can factorize there, so that we have got log 9 minus log 4 in this case. Then I'm taking out a 2, then the bracket will be log 9 minus log 4. That is basically what I'm doing there after factorizing. Now you can see that I can now cancel out this inside the bracket and cancel out that inside the bracket. Now students sometimes are tempted to say they want to cancel it like that, and they cancel it like that. Then you'll have 2 minus 2 is equal to 0. Then you'll be penalized of that. What is important? First, you need to factorize. So when you cancel, the top will give you a 1 and the bottom will give you a 2. Hence, you can see the answer there is 1 over 2. So that was a way, a simple way of solving this particular problem. There were other ways you could have done to say, some students would have approached it to say they want to write 9 as 3 squared and then 4 as 2 squared, which means also 81. You're supposed to express 81, and in terms of 3, 81 I think is 3 to the power of 4. Let's check that. Yes, 81 is 3 to the power of 4 and 16 is 2 to the power of 4, I think. So you could have expressed 81 as 3 to the power of 4 and 16 as 2 to the power of 4. So with that, it was another option there. If I can use a different marker here, it was another option in terms of 3, whereby we are going to have in this case 2. If you drop, remember it's 3 squared, 2 log 3 minus 2 log 2 over, now the 81 is 3 to the power 4, which is 4 log 3 minus 4 log 2. So you see that you're expressing everything in terms of 3 and 2, and then this was going to simplify then to become, you factorize 2 on top, it is log 3 minus log 2 all over, and then you've got 4 log 3 in this case minus log 2. So you're going to do that so that you've got now 2 over 4, and still it is 1 over 2. That was one way of doing it. Or alternatively, someone would have approached it in this part, whereby just from the top here, you want to apply the laws of logarithms when we are subtracting. Remember, when you use the laws of logarithm, when you subtract, you divide, so that it was going to be log 9 over 4 over log 81 over 16. Remember, this is these are laws of logarithms in this case, which is equal to now 9 in this case, and 4 is, we can leave it like that to say log 9 over 4, and then over, now 81, remember we said is log 9 squared over 16 is 4 squared. And then if you continue with that, if I can continue with that part, it would have been equal to log 9 over 4 over, using laws of exponents, this is same as saying log 9 over 4 everything squared, because it's 9 squared over 4 squared. And then at that point, I'm going to then, using the law of logarithm that we talked about here, the 2 was going to come down there, and when it does that, I was going then to have equal to log 9 over 4 over 2 log 9 over 4. Now you can see that the log 9 over 4 and the log 9 over 4 goes, so that you get your answer as 1 over 2. So there were many options that you could have tried or used to try to solve that one. Now let us move on to the next one. The next one is now question 1.2 of question 1. So we've got again 1.2.1, which was 4 marks. Now it says you are solving for x in the equations. I think it'll be much clearer. You can see the question says solve for x. As I said, this was 4 marks there. So if I can even expand further, I'm solving for x in this particular question. So I'm given that part, it's exponents, and I'm supposed to apply the laws of exponents. So now, if you look carefully, you are given 16 to the power of that, and you're given 64 to the power of that. So it is up to you how you want to approach it. But one of the ways with exponents is always to match the bases. So you have to match, write 16 in exponent form, write 64 in exponent form, and match the bases. Now let us start with 2. I think we have already proven that 2 to the power of 4, see, it's 16, and 2 to the power of 8, it's 6. I mean, Oh, okay, that's interesting. Actually, 2 to the power of 8 is 256, which means 2 to the power of 6 is 64. So you can see that you can express all these in terms of 2, or if you wanted to do it in terms of 4, 16 is 4 squared, and then 64 is 4 to the power, I think it's 4 to the power of 4. Oh, actually 4 to the power of 4 is 256, which means 4 to the power of 3 is 64. So it's up to you whether you wanted to do it in terms of 4 or in terms of 2, but I prefer using the smallest one, which is expressing it in terms of 2. So remember, as I said here, 16 is 2 to the power of 4, and then 64 is 2 to the power of 6, and 256 is 2 to the power of 8. This is in terms of 2. You can write it in terms of 4 in this case, which is equal to 4 squared, which is equal to 4 to the power of 3, which is equal to 4 to the power of 4. So whether you choose 2 or 4, you can see as long as it is matching across, it means you can choose any either, and I'm going to take the one for 2. So what I will have is I will have 2 to the exponent of 4. Now don't forget, you need to add a bracket for the x plus 2 there. It is very important. Always include a bracket there, over 2 to the power of 6. Again, the bracket is 2x plus 1, and then this is equal to 256, and you can express 256 as 2 to the power of 8. As I said, it is another way of solving that. Now, or you can even leave it as 256, is still fine. But now, what do I do after? I have now, as you can see, I have managed to write everything in terms of 2. So I can expand the bracket now to say that and that, as well as that and that. It will become equal to 4x plus 8 over 2. 6 times 2 is 12x plus 6 is equal to 2 to the exponent 8. So that is that. And then now I need to take this 2 to the top. Now it will become negative. It will become 2 to the power 4x plus 8 dot 2 to the power minus, you put a bracket, and then you've got 12x plus 6 in this case is equal to 2 to the power of 8. So you see that now the bases are the same, so we add the exponents. So it's 2 to the power 4x plus 8 minus 12x plus 6, don't forget the bracket, is equal to 2 to the exponent 8 in this case. So now the bases here, as you can see, are the same, and with the equation in exponents, if the bases are the same, remember it says if a to the power of x is equal to a to the power of y. So the bases are the same, therefore we can conclude that x, the exponent, is equal to the other exponent, which is y. You equate the exponents. So even here you can see we have a 2 and we have a 2, therefore we can conclude that this exponent is equal to that exponent. So it means 4x plus 8 minus, if I can open that bracket, it's minus and then it's minus, so it's minus 12x minus 6 is equal to that exponent, which is also equal to 8. Now collect the like terms, which is 4x minus 12x is equal to 8. This 8 will go and join the other side, which is 8 minus 8 plus 6. Now 4x 4 minus 12, which is negative 8x, is equal to that, and that will cancel to give you a 6. You divide by negative 8, and I divide by negative 8 such that I've got my x is equal to, just with my calculator there, but it's negative 3 over 4 there, so it's 6 over negative 8, which is negative 3 over 4. So that was my value of x in this particular answer. So my x is negative 3 over 4. But with equations, you definitely need to take your answer to the original and see whether it balances, because you can actually test your answer. So if x is negative 3 over 4, you come to the original. Where there is x, you are going to where there is x here, you're going to have your negative 3 over 4 there, and then even here you're going to have your negative 3 over 4, so that you can substitute it and see that it gives you 256. So if I can now use that to say 16 to the power of x, remember x in this case is negative 3 over 4, so it's x plus 2, right, over 64 to the power 2 into, and then it's negative 3 over 4, close the bracket, and then it's plus 1. Now when I simplify that, I must get 256. You can see that it's giving me the exactly 256. It means my value of x, therefore, that's how you test your answer, is definitely correct. So you can mark yourself with equations, keep on taking the final answer into the original. You are going to be able to see if you're doing the right thing. That is the last question, and this last question is out of 3, and total question 1 was out of 15 marks. So now let us look at 1.2.2. Says half log in base 7 1 over 49 is equal to x. So we are again solving for x. In this case, the question is solve for x in the following. Now look at this. It's 3 marks, and we're supposed to solve for x. So a few things that you need to note. The thing that you need to note here is the 7 there as a base, and the 49 here. Remember 49, if you take calculator, that's what they were trying to trick you on. And then if you say 7 squared, you see 7 squared is 49. So this is actually 7 squared. So if you can rewrite this, you are then going to have equal to 1, not equal to, you can put an arrow to say this leads to 1 over 2 log, in this case, in base 7 of 1 over 7 squared is equal to x. Now using the laws of exponents, I need to take the 7 to the top so that it becomes, remember, it's like I've got 1 over a to the power of m. It is equal to a to the power. When it goes to the top, the division sign disappears, then it's replaced by the negative m. So that's what I'm just doing there using the laws of exponents. So it's 1 over 2 log in base 7, and then 7 to the power negative 2. This is equal to x. Just like we were previously, as I was showing you with the laws of exponents, this particular negative 2 will drop down to join the 1 over 2. When it joins the 1 over 2, it multiplies the 1 over 2. So you must include a bracket. So you'll have 1 over 2, and then a bracket, you put in negative 2 there, and then you have got log 7 of 7 is equal to x. we have looked at all these different laws in the previous question 1, 2, and 3, so that's why I'm just applying them now. And also, for more in-depth knowledge on these, I will encourage you to grab hold of my lesson on exponents, or my mathematics N2 for the underdogs. It explains in detail when it comes to these laws of exponents. Again, have a look here. I've got a base of 7 and a number 7. Remember, this become 1 altogether, such that I have got now, so this and this will also cancel to give me -1. So I've got -1 into 1 is equal to x. So -1 times 1, therefore x is equal to -1 in this case. So this was the value of x when I'm simplifying. So now the question was simplify that. I can now take a calculator and see if it gives me the same answer as x is equal to -1. So I've got here 1/2 log base 7 of 1/49, and then if I do that, it gives me -1. So you can see that definitely my value for x there as -1 is correct. So this is how you could have approached question number 1 when it wasn't a complicated questions. You just needed to know especially your laws of exponents. I think the examiners were very into the laws of exponents as well as logarithms, and if you did cover those topics in depth, you're going to get all the 15 marks without much problems. And again, I will encourage you to grab hold of my mathematics N2 book. It comes with videos. It's the full curriculum of maths with videos, and in that particular book I cover a lot of examples, and the laws of exponents as well as logarithms are covered in detail. We have come to the end of our lesson. Thank you.